This is section 4.6, problem number 15. I wanted to do this one and I'll record another one that's a definite integral using U substitution. So by definite integral, that that means that you have these numbers here, like the 5 and the 15. Versus the antiderivative, like the previous problem, like notice there are no numbers at the bottom of the little integration symbol. So the 5 and the 15, that's what makes this a definite integral. And I didn't do any examples of the using U substitution with definite integrals in the lecture video. So I just wanted to do one right now. So this is number 15, and I wrote the problem down. It's asking us to find the definite integral from 5 to 15 of natural log of x squared over x. So going back over to the iPad, and so I'm going to follow like those, the rules for, I said, maybe you don't know. That's why I'm kind of laughing at myself. I'm going to follow the rules that that I talked about in the lecture for section 4.6 for integrating using U substitution. So I'm just going to like follow those steps. So the first step was to pick like a U. So like you start off, because we have a definite integral, we are going to use the fundamental theorem of calculus to evaluate this expression. And so in order to use the fundamental theorem of calculus, we have to start off by finding the antiderivative. So like the first thing that we're going to do is find the antiderivative of natural log of x squared over x dx. Not worrying about those numbers, the 5 and the 15, the lower and upper limit or the limits of integration. We start off just finding the antiderivative, just with the same that you would do with any definite integral if you're using the fundamental theorem of calculus, which we are definitely using. So I'm going to find the antiderivative of this natural log of x squared over x, which means first thing I'm going to do is determine or pick a U. And I'm just looking at this, and I know that the derivative of natural log of x is 1 over x, which appears in this function. So I'm thinking a good U in this case is natural log of x. And again, the reason I'm thinking this is because the derivative of natural log of x is 1 over x. So I'm like, yeah, it looks like that would be a good U, natural log of x. So once you pick your U, then you find your du. So that means I'm using this little formula for dy, which is so the differential f prime of x dx. So I'm using that same formula. So I find my u prime, which is 1 over x. And then I have d. In this case, I have, 1 over x dx. So from here, I'm going to go ahead and solve for my dx, which means since what's keeping dx from being by itself is that 1 over x, I can get rid of this x by multiplying both sides by x. So I'll multiply both sides of this by x. And what happens is this x and this x cancel each other out. So now I just have dx equals x du. Now I'm gonna make the substitution, which is why this method is called U substitution, because we're substituting U in. So I'm gonna go back up to my original antiderivative, and let's see, I will replace my natural log of x. I'm going to replace that with u. So I will have, what will I have? I will have u squared instead of natural log of x squared. And I have my x down here. And then I'm going to replace my dx with x du. So this is times x du. And then I get to, look, I'm happy because I get to cancel out my x's. So I know I'm on the right path if I can, if all of my x's get canceled. And I'm gonna turn off my video, make sure I'm not blocking something. Which they did. And so I'm left with the antiderivative of just u squared du. And I know that this is u cubed, sorry, not x cubed, u cubed. U cubed over 3 plus c, using this rule that the antiderivative of x to the n dx is x to the n plus 1 over n plus 1 plus c. So I'm happy there. So, okay, from here, now I'm gonna go, oh, whoops, I'm not quite done. Let me just go ahead and make my substitution back because u was natural log of x. So I'm gonna just go back and replace this u with natural log of x. So I end up with natural log of x cubed over 3 plus c. So now I will go back to the original problem, the one that's the definite integral, right? So fundamental theorem of calculus says to find a definite integral, to evaluate a definite integral, what you need to do is find the antiderivative, which I just found. So I'm gonna go ahead and write the antiderivative up here. So I have natural log of x cubed over 3. And then I don't have to put the plus c because I'm about to evaluate this from 5 to 15, which means I need to plug in the top number for x. So I'm going to plug in 15 for x. So I have natural log of 15 cubed over 3. And then after that, I will plug in the bottom number for x. I'm just picking the perfect color. The perfect color. What color? Oh, I like these colors here. They're kind of, this one's pretty. So I'll plug in the bottom number for x. So I have minus natural log of 5 cubed over 3, and I'm done. This should be my answer. Let's check it. Let's check. Natural log of 15. Oh, whoops. Oh, I keep forgetting they like automatically put parentheses, like right if you type anything right after you type natural log, it automatically puts parentheses there. I'm just gonna copy this and paste it. Minus, and this isn't, it was natural log of 5. Yay. Now I just want to show you there's a different way you can approach this problem. And this is for all of the u substitution definite integral problems. Another way that you can do this is, so here, let me copy this I'm copying and pasting. I really recently learned how to do this copying and pasting with this, except of course I have not perfected my technique yet. So let me try this again. There. Okay, so there's the original problem, right? Now, so you can go through like the same process where like you let u be natural log of x. I'm like letting u be natural log of x, right? And then from there, finding that du is, oh, by the way, let me just say before I do that. So once you find your u, right? Or once you determine what your u is going to be, like what I just did, then one thing that you can do is you can like look at your lower limit and your upper limit. Look at these numbers, right? And you can determine what those numbers would be if you kept your answer in terms of u. So here's what I mean. So at x equals 5, that's the lower number. U is natural log of 5. And then the top number at x equals 15, u will be natural log of 15. And then what you can do is basically like go through the same process I just went through, right? So do all this stuff. I'm not going to do it all again, but you're like, you do all this. You make your substitution. You do all this. You get here. You get to this spot. I'm going to color it in blue. So you get here, what I'm circling in the right-hand corner. U cubed over 3 plus c. Oops. U cubed over 3. You don't have to do the plus c part. But then instead of like changing this to being in terms of x, back in terms of x, you can keep it in terms of u. And replace the 5 with natural log of 5. So down here you'll have natural log of 5. And then replace the 15 with natural log of 15. So up here you'll have natural log of 15. And then apply fundamental theorem of calculus again. So we'll have natural log of 15 cubed over 3. Like you plug in the top number and then plug in the bottom number. Natural log of 5 cubed over 3. So that was kind of nice because you don't have to change the u back to whatever it was defined as in terms of x. You can just keep your u. Just make sure that you change these numbers. So take care. Bye.